So let's move on. In your new book, Thinking About Evolution, which I encourage people to pick up, it's available at Reasons and on Amazon and wherever you buy books, reasons.org, that is. You write a chapter on chemical evolution. Another word for that is abiogenesis. It's the start of life from non-life. In our Best Facts book, in our Tall Tales acronyms, this is the L in the Tales acronym. Life doesn't come from non-life. So my question to you is, can life come from non-life? You wrote a chapter on it. Tell us a little bit about what you share in that chapter.
Yeah, well, the bottom line answer is nobody knows how chemical evolution could produce the very first cells, starting with, the molecules that would be present potentially on the early Earth. And so we do have a chapter on that in the book. We also have a couple of other books that people might be interested in, Origins of Life and Creating Life in the Lab, where we really roll up our sleeves and we get into the nitty-gritty, scientific details of, different facets of chemical evolution and why these different approaches simply don't work. But the bottom line is, every attempt to try to explain how life could emerge through chemical evolution, and there's a number of different disparate approaches that have been used, all wind up leading to dead ends. They all wind up, and yet I think many people who are listening to this might be familiar with some of the experiments that people have done over the years that seemingly validate chemical evolution or abiogenesis. Like the Miller-Urey experiment is a textbook example that people have probably heard of, where Miller in the 1950s set up a glass apparatus where he had a flask of boiling water that was designed to mimic the early oceans, and he evacuated all the oxygen out of the head space and then introduced hydrogen and methane and ammonia and had an electrical discharge that was presumably representing lightning and could form amino acids and other organic materials fairly quickly in that setting. And so the argument was like, well, this, in effect, it validates the idea that chemistry could produce the building block materials needed for life, and that they could complexify and evolve towards the very first cells. And people have done countless number of experiments in this vein where they've gone in the lab and they've tried to simulate conditions on the early Earth. But the problem with these experiments is that they ultimately prove to be artificial, that these are highly controlled experiments under very precise and exacting conditions, that, those exacting conditions and that exertion of researcher control is so critical to the success of the experiments that it's highly unlikely that these reactions could ever be truly productive under the conditions of the early Earth. And so the flaw really in these experiments is what we might call unwarranted researcher involvement. The researchers have involved themselves to such a degree that what they're doing now is not mimicking the conditions of the early Earth, but are illustrating what could happen if an intelligent agent is overseeing the process. And so, that to me is really the Achilles heel. So, Origin of Life researchers have been successful at saying, hey, in principle, these are some of the chemical and physical processes that could contribute to the origin of life. They've been successful in teasing out the mechanisms, as you would say, the pages and pages of reaction mechanisms. But it's through that process that they understand how exacting and precise the conditions need to be for this chemistry to be productive. And so the work in the lab is irrelevant to the geochemical conditions of the early Earth. And so, if anything, ironically, people working in prebiotic chemistry have provided clear evidence that intelligent agency is necessary for chemical evolution to take place, or for life, more precisely, for life to come from a collection of chemicals.
Again, we're seeing the predictive value of the creationist model. It's exciting. Most people here haven't taken organic chemistry, but if you have, you're familiar with chirality. And I know that's a major hurdle. So even if we could get some organic molecules, getting the right ones to link up the right way is statistically impossible. And so they have tremendous hurdles with all of this. So can life come from non-life?
The bottom line is no. And again, you can go into the literature and look at the work of in the statements made by origin of life researchers who are vested in an evolutionary explanation for the origin of life, who would not be friendly to a Christian worldview, who readily will acknowledge we have no clue how life emerged on Earth. And really, the insistence on chemical evolution is more an a priori commitment than it really is based on the evidence at hand.
So let's say there was a process that could form just an original RNA strand or DNA strand or something like that, just something that could hold biological information. The question is, can evolutionary processes generate new information? That's actually the title of one of the chapters in your new book written by your co-author, Dr. Roberts. Can evolutionary processes generate new biological information?
To me, it's the answer is yes and no. In principle, evolutionary mechanisms can generate information, but when you're talking about this happening in the context of the origin of life, let's say you had this hypothetical RNA molecule that had a random nucleotide sequence. Could it evolve, to produce a molecule that would have information and that would be biologically functional? Well, you can go in the lab and you can do these in vitro evolution experiments and produce those kind of RNA molecules all day long. Nobody's been able to produce a self-replicating RNA, but you can produce RNA molecules that have some very interesting biochemical function. The problem is very similar to what we were talking about with prebiotic chemistry. The problem is that as soon as you try to take those conditions that you need for in vitro evolution to work in the lab and try to envision how they would happen on the early Earth, everything unravels. And so, yes, evolutionary mechanisms in principle could produce information, but in practical reality, it's very difficult to see how that would actually work in the origin of life context. I guess the answer is yes and no. Yes, under highly contrived conditions where you have researchers rigging things in such a way so that evolution has the best chance of doing that. But under a natural setting, it's highly unlikely that information could emerge and the level of information that you would need to emerge to support life. So it's one thing for a biomolecule to emerge with information, but it's another thing entirely for an entire cellular system to emerge with all the information you need to specify the parts of that cell and then to regulate the activity of those parts. So this is what Paul Davies refers to as the algorithmic information problem. And so there's no way to account for not only the information you would need to specify the biomolecules, but the set of instructions that would have to exist to regulate the behavior of those biomolecules that are instantiated in information. So Paul Davies would argue, hey, we can explain the origin of what he calls simple information. We can't explain the origin of algorithmic information through evolutionary mechanisms.
That's a good way to put it. Natural selection and mutations might explain how you get blue eyes instead of brown eyes or something like that, but they're not going to explain eyes.
That's a great way to encapsulate it, Nate.